All right, this video is going to help us understand how to solve absolute value equations. Now, in order to understand how to solve equations using absolute values, we should remember how to evaluate them, how to kind of go forward with them before we end up going backwards. So again, to take a value and plug it in to an absolute value equation, such as x equals 3, we're going to plug x equals 3 in here. We're going to take out the x, we're going to plug in the 3. Then you notice we're going to start inside the function. So 3 minus 3, which would be 0. The absolute value of 0 is 0. Multiply that by a half, which is still 0, and then add 5 when we're finished. Now, anytime that absolute value, again, is taken of a positive number, really it's not changing the number at all. So let's look over here when x is 5. 5 minus 3 is 2, and again, the absolute value of 2 is 2. Cut it in half, add 5, equals 6. When we plug in 15, same idea. 15 minus 3 is 12. The absolute value of 12 is 12. Add times a half, add 5 is 11. But now, look what happens when we plug these two numbers on the bottom in. When I plug in 1, we subtract and get negative 2. The absolute value of negative 2 is positive 2. Remember, the absolute value is the distance from 0, and both 2 and negative 2 are 2 units from 0. So again, the absolute value becomes a positive number. We still cut that number in half, then we add 5 afterwards. Negative 9 minus 3 is negative 12. Again, the absolute value of a negative 12 is positive 12. Cut that number in half, add 5, we get 11. Notice that two different x values gave us the same y value. Same thing happened with 5 and 1. They gave us the same y value. Well, the problem is when we're solving equations, we're going to start with that final value, right? Start with the 11, or such as the problem on the next page. That same equation, when would that value have been 17? When would it be equal to 17? What x value or x values, right? What two different numbers could I plug in that would have given me back the same number, 17 there? Well, let's start with a simpler equation first. Over here at the left, we're really considering the question, when you're solving an absolute value equation, what number, right, is exactly 5 units from 0? Well, it makes sense that to the right of 0 is the number 5, but to the left of 0, 5 units as well, would be negative 5. So we really get two different answers. X could have been 5, because the absolute value of 5 is 5, or x could have been negative 5, because the absolute value of negative 5, such as down at the bottom of the screen here, also equals 5. Another way to write that, just a quick little shortcut, is to say plus or minus 5, because it was the same answer, just one positive, one negative. So you can write it out like that if the numbers are identical, right, or are opposites, I should say, 5 and negative 5. But again, the idea is we get two different answers. The distance from 0 being 5 units could happen positively or negatively. So let's try this one over here at the right side. 17 then would be equal to 1/2 x minus 3 plus 5. We knew what y was, so we're just going to plug in for y in our equation. Now remember, on the previous screen, the last two things happening were always this plus 5, right? That was the last step. And right before that was cutting that number in half, right? It was half of 0 or half of 12, right? So again, those will be the first two things we get rid of when we're solving. They were the last things happening. They're going to be the first things to go. So plus 5 means I'm going to subtract 5. 12 equals 1/2 the absolute value of x minus 3. Then we can divide by a half. Right? I want to get rid of that half value. So divide by 1/2. Now the same thing, if you divide by a fraction, the same thing as dividing by a fraction, remember, is multiplying by its reciprocal. Oops, 2 there though, right? Reciprocal of a half would have been positive 2. Let me clean that up just a little bit here. Again, instead of dividing by a half, I'm just going to multiply by 2. Make sure you do that on both sides, and we'll find out that 24 is equal to 1/2 of x. Oops, sorry, we got rid of the half. Right? we canceled that out, didn't we? Times 2 times a half. Times 2 times a half, they're going to disappear. And all we get left with is, or have left, is this absolute value of x minus 3. Let's go ahead and split those two parts now. This is kind of the important step today. Kind of like on the left, again, if the absolute value is equal to a positive 5, well, our answers could have been positive or negative, right? We get rid of the absolute value and consider it either plus or minus. Well, let's do the same thing. Let's get rid of the absolute value, right? X minus 3 both times. But it could have been equal to positive 24, or we could be equal to negative 24. Now, there is a slightly better way of doing that, because I like to say if we're going to get rid of the absolute value, then the real change is happening on the side with the absolute value. So I always like to sort of consider this either positive x minus 3 came out to 24, or a negative of it came out to positive 24, right? In which case, you could immediately divide away that negative 1, and we'll get x minus 3 equals negative 24. And if you add 3 to both sides, again, kind of running out of room here, so I'm just going to write it over here. X could be equal to, again, negative 24 plus 3 is a negative 21. In the first problem over here, we didn't finish quite yet. Don't forget to finish them both. I'm going to add 3 to both sides, and x could have also been positive 27. So we could get either of those two good answers, right? 27 or negative 21. Plugging either one of those back into the original, 27 minus 3 is 24. The absolute value of 24 is 24. Cut it in half is 12, plus 5 is 17. Negative 21, on the other hand, in here, negative 21 minus 3 would have been negative 24. The absolute value is 24. Cut it in half, add 5. Still equal to 17. Both of those answers are perfectly good solutions to our equation, right? They're the only two numbers I could plug in for x and get back 17 for a value. Let's do one more problem really quickly here. If you want to see a couple more examples, there is a second video. It's going to show you kind of a special case. Make sure you watch that video as well. But it'll show you a couple more examples of solving these equations, as well as a way to apply this idea. But now let's try this one more time here. So let's go ahead and take our equation. Again, the first thing we want to get rid of is anything outside the absolute value. We want to isolate the absolute value. So let's get rid of this plus 12, because it has nothing to do with the inside, right? Nothing to do with what's inside the absolute value. Let's get rid of that minus 12. Absolute value of x plus 3, right? Not changing anything else, would be equal to plus 12 minus 12 is gone. And we are equal to 32 minus 12, which is 20. Now we're going to split again into our two parts. We can say positive x minus 3, or negative, sorry, x plus 3. Fumbling my words there. Or negative the quantity. Negative x plus 3. Notice I haven't changed anything from the original equation when I put that negative on. I'm going to just tack a negative sort of in front, almost like it's in front of the absolute value, so that if this number came out to a negative value, I would take another negative and end up at positive 20, right? It's sort of forcing this interior part to be negative so that we can force it right back to being positive. Now let's continue to solve. We're going to subtract 3 on both sides. Negative x equals 17, or now you kind of have an option. You can distribute this negative 1 in front to each part, or what I tend to do is just go ahead and divide that negative 1 over to the other side. So we're going to cancel, right, this negative 1 with the negative 1 that's out in front. So don't lose your negative inside. Still negative x plus 3 is going to be 20 divided by negative 1 is negative 20. In that case, then we can subtract the 3 in this problem, and negative x will equal negative 23. And finally, for each one of those, I don't want to leave it as negative x, so I'm going to divide by negative 1, right, in all parts. And x could have been negative 17 over here at the left, or negative divided by negative, positive 23 from over at the right. Again, take those numbers, plug them back into your original equation, make sure that they actually get you the right answer. But again, if you have any questions, make sure you talk to your teacher. Otherwise, have a great day.